Welcome to the podcast on solving literal equations. The good news here is that solving literal equations is pretty much the same as solving any other linear equation, and we've already learned the methods for doing that. In general, when we're faced with a new equation, if it has fractions in it, most of the time we want to eliminate those fractions. Once we get the fractions eliminated, we want to follow the 4 steps. I've shown the 4 steps up here in the corner. Get x out of the parentheses. Now again, the thing that you're looking for doesn't have to be called x. I'm just using x kind of as a generic variable here to save time. Get your x terms to one side and your non-x terms to the other side. Step 3, form a single x term by factoring x out. And step 4, reverse what is done to x. So let's go ahead right into the examples. We take a look at example 1. First thing I want to note is how many terms are in example 1. Now terms are products, and they are products that are separated by plus or minus signs. So if I had this expression, that is actually just a single term. And the reason it is a single term is because when you see a bracket like that, we consider that bracket to be a single number. And since that's a single number, we have no pluses, we have no minuses, we have no equals, so that's just one term. Okay, let's go to example 1. In example 1, we have 2 terms. The 2 terms are separated by the equal sign. And we're supposed to solve for B1, and we notice that we have fractions. And we've said before that a very good first step in just about all cases that have fractions is to get rid of the fractions. And the way you do that is you multiply each term by the common denominator. Well, I only have 2 terms, one on the left and one on the right. The common denominator is 6, so I'll say 6 times the first term is equal to 6 times the second term. And on the left side, the 3 cancels the 3, leaving a 2, which leaves the left side as 4a. And on the right side, the 2 cancels the 2, leaving a 3, which on the right side gives us 3h times b1 plus b2. Now notice I didn't multiply the 6 by half and then multiply the 6 by the h and then multiply the 6 by the bracket. I only used that 6 once, and that's because inside of this big bracket there's only one term. If there were 3 terms there, I'd use the 6 3 times. But that's one term, it's all multiplication in there, so I only get to use the 6 once. Now that I've gotten rid of the 6, I follow the 4 steps. The first step says get the x out of parentheses. Well, this time it's not x, it's b1. So it's telling you to get the b1 out of parentheses, and you do that by distributing. 3h b1 plus 3h b2. Step 2 says get all your, in this case, B1 terms to one side and your non-B1 terms to the other side. We'll only have one B1 term, and it's already on the right side. So what I need to do is get my non-B1 term, which is 3HB2, over to the other side with my other non-B1 term. So I subtract 3HB2 from both sides. And on the left, that gives me 4a minus 3h b2 is equal to 3h b1. Step 3 says to form a single b1 term. Well, I've already got a single b1 term. A single term just means one term, and that's one b1 term, so I don't do step 3 at all. Step 4 says reverse what is done to b1. Now, in order to reverse what is done to B1, you have to know what is being done to B1, and B1 is being multiplied. It's being multiplied by the number 3h. So if I want to reverse multiplying by 3h, I divide by 3h. And on the left side, the 3h's cancel, leaving me with b1. On the other side, the 3h's do not cancel. That is because in order to cancel, you must have all multiplication, numerator and denominator. You'll notice in the numerator there is a subtraction. That means canceling is not allowed. So my final answer, 4a minus 3h b2. Uh-oh, I'm getting in the way of my other problem here. Let me put this down below because I don't want to get in the way of example 2. So I end up with, well, I'll just do it this way. I'll just box this answer. Since I can't cancel, since I can't simplify that answer by canceling, I'll just say that b1 is equal to 4a minus 3h b2 all over 3h. Now let's move on to example 2, and if you'll notice, the problem in example 2 is exactly the same problem as the problem in example 1. That is 2/3 a is 1/2 h times b1 plus b2. The difference is in what we're solving for. This time we're solving for h. But the steps are still the same. We go through the same steps we would go through anyway. Since we have fractions, since we have two terms, since the common denominator is 6, we'll multiply each of our two terms by the common denominator, just as we did before. And there you have it. 6 multiplied onto both terms. On the left side, the 3 cancels the 3 and the 6, leaving a 2, and that leaves the left side as 4a, just as before. And just as before, the 2 cancels the 2 and the 6 and leaves the 3, so that gives us 3h times b1 plus b2. Now, notice a big difference. The second one says get your x, get the thing you're looking for, out of the parentheses. In the last problem, we were looking for b1. b1 was in the parentheses, so we distributed right here to get b1 out of the parentheses. But now we're looking for h. h is not in the parentheses, so we do not have to get h out of the parentheses, and I'll tell you now, if you distribute that 3h, you're going to make this problem real hard and probably too hard to solve. So understand now, since the variable we're looking for, the h, is not in the bracket, we do not distribute that 3h. We go to step 3, which says get your h terms on, or step 2, which says get your h terms on one side and your non-h terms on the other side. There's only one h term, and that's it. There is no other h term, so it is clearly on one side. This is my non-h term. It's on the other side, so step 2 is already done. Step 3 says form a single h term. That is a single h term. That's only one term. That's 3 times h times bracket, and bracket stands for one number. So that is all one single term. So we didn't have to do step 1. We didn't have to get h out of a parentheses. It wasn't in a parentheses. We didn't have to do step 2, get all our h terms on one side. We already had all our h terms on one side. We didn't have to do step 3, form a single h term. We already had a single h term. All we have to do is go straight to step 4 and say, reverse what is done to h.